So welcome everyone to the In the Field webinar series. This is actually the last one that we have planned for this season. So we're excited. If you haven't had a chance to go view all the other ones, make sure you go to the Alberta Wheat or Barley Commission website and you can find all the previous webinars there. I am Jeremy Boychin. I'm the Commission's Agronomy Extension Specialist. And I'm going to be the facilitator for today's webinar. And I have here with me Dr. Charles Geddes. Give a wave. Thank you, Charles, for joining us today. Before I let Charles begin, I just want to give a quick piece of information to get moving on the webinar and make sure all the interaction is going to go smooth. So the commissions like to have a hands-on approach when it comes to agronomy and extension. This is why we've kind of developed the Growing Point, which is our agronomy extension network. We aim for timely, relevant agronomic resources. Considering COVID this year, we've had a lot of challenges bringing people together. I'm sure many of you have had events that have been canceled. So we decided to try and bring researchers closer to agronomists and industry people and producers by doing this in the field webinar series with timely information. So these webinars are focused on helping producers stay connected with these industry experts and hopefully bringing something back to the farm. So in today's webinar, Dr. Charles Geddes is going to present for, I think, about 30 to 40 minutes, it sounds like, on weed resistance around harvest timing. At the end of the presentation, we'll open it up for Q&A. So if you have questions that aren't directly related to the slide at hand, hold on to them to the end. If you do have a question that relates to a direct slide that Charles is going through, you can interact in 3 ways. There's a Q&A button at the bottom of the page. In there, you can ask a question and then we'll address it. You can raise your hand, and when you raise your hand, which is the button you can see there, I believe it's at the bottom of the page as well. It allows me to give you the microphone and you can ask Charles directly over the microphone. And then the last option is the chat function. So if you go to the bottom of the page, open up your chat function, and then on the right side of your screen, the chat function will open. And then at the bottom of the chat function, there's a drop-down menu. You can see it says all panelists right now. Click that and click all panelists and attendees. That allows you to type and text, and everyone in the webinar can see what you're asking. So we can kind of build conversation off that. So again, clicking the chat, clicking the drop-down menu in the chat and changing it to all panelists and attendees. So again, if you want to address slides that are current, feel free to use any of those options. Otherwise, feel free to wait to the end for the Q&A session. Lastly, we always highly encourage sharing on social media. So if there's something that you think is important or you want to take a screenshot and share it on social media, make sure you hashtag the Growing Point and then tag Alberta Wheat and Alberta Barley. If you feel like tagging me, Boychin Jeremy, feel free to do that as well. I'll be happy to engage with you on Twitter as well. So that is everything. And now you're going to stop hearing from me and we will let Charles have at it. So take it away, Charles.
Okay. All right. Well, thanks everyone for joining. And yeah, so my name's Charles Geddes and I am a research scientist with Agriculture and Agri-Food Canada based out of Lethbridge, Alberta. And my research program mainly focuses on herbicide resistance. So that's identification, monitoring, and management of herbicide-resistant weed biotypes across the Canadian prairies. And before I get started, I should also mention that this webinar is actually a follow-up to another in the field webinar that we offered previously in late June. And Jeremy, is there a link that people can go to access the last webinar as well?
Yeah, what I'll do is I'll post that link in the chat box, but otherwise they can go to the Alberta Wheat Commission events page and there'll be a link to your previous webinar in there.
Great. Okay. Yeah. So again, this is a follow-up to a previous webinar. The previous webinar focused on looking for or scouting for herbicide resistance after your post-emergence herbicide application. And this webinar is more focused on this time of year where we're looking at collecting samples for herbicide resistance testing, and that's either pre or post-harvest. So we'll be talking about three main things. The first two things are more of a background, looking at the current status of resistance in two of the big problems that we have here on the prairies, which is multiple resistance in wild oat and in kochia. And then we'll talk about what you can do at this time of year as far as accessing some herbicide resistance testing services to help you understand what type of resistance you're dealing with. So in general, this is a global map looking at the number of cases or the number of unique cases of herbicide resistance. And what I mean when I say a unique case of herbicide resistance, that is a weed species by herbicide mode of action combination. So here you see the darker red in a country means a higher number of unique herbicide resistant weed biotypes. So in Canada, currently we're sitting in third place, trailing behind. Currently we have about 76 unique biotypes across the country, and that's trailing behind the United States and Australia. So focusing in on Alberta, this is the timeline of discovery of unique herbicide-resistant weed biotypes over time, and you can see generally, the discovery of new types of resistance, it has sort of followed a linear trend over time since the late 80s and continues to do so. And also behind this figure, you can see these different colors indicating various weed surveys or herbicide-resistant weed surveys that have happened over time in Alberta. Starting off with surveys that focused mostly on grasses, mainly wild oat, but also some green foxtail. Then going into the blue here, you can see this is the Prairie herbicide-resistant weed surveys. So the current format that looks at between 20 and 30 species across the entire prairies. And over here in green, these are the more recent post-harvest surveys focusing on herbicide-resistant kochia and Russian thistle. So currently in Alberta, we're sitting at 26 unique herbicide-resistant weed biotypes. And obviously that's important when we consider that we have a limited number of herbicide modes of action. So this figure here is showing the increase or the release of new herbicide modes of action over time. And at first glance, it looks like there's quite a few, starting generally in the 1940s and increasing again over time. But the main point here is that the last real herbicide mode of action was released in the late 80s. And we've been essentially 3 decades without the release of a new herbicide mode of action. So we're seeing an increase in herbicide-resistant weed biotypes and unfortunately a stagnation in the release of new herbicide modes of action. So most of the herbicides that have been released in the last 3 decades are just reformulations of old herbicide modes of action. So one of the projects which I'm leading was previously led by a researcher, Hugh Becky, out of Agriculture and Agri-Food Canada, Saskatoon. And these surveys, this is the Prairie herbicide-resistant weed survey, and it covers between 20 to 30 weed species that are dominant across the Prairie region, and essentially looks for the frequency of herbicide resistance throughout the prairies. So these surveys have kept the same methods since the early 2000s, which allows us to quantify resistance over time. So these surveys, essentially what we do is before harvest, so late enough for the weeds to be in the field to be mature, but before harvest, we visit these fields and collect samples from any visible weed patches and bring those seed samples back to the lab where we harvest them out, and in the greenhouse we grow out the plants and treat them with various herbicides under controlled environment conditions to look at the incidence of resistance in those weed populations. And this survey covers about 800 fields across the Prairie region over 4 years. So the last round of the surveys that was led by Hugh Becky was between 2014 and 2017. And the current round is from 2019 to 2021. So these surveys are the source of most of the main information on herbicide resistance across the prairies, and they provide a lot of value to farmers, agronomists, and also the agricultural industry because we can document resistance over time. So this is just one of the main metrics that we can pull out, looking at the percentage of fields in each province that have at least one herbicide-resistant weed biotype. And you can see that this metric has increased over time. So there's more and more fields that we're seeing that have at least one herbicide-resistant weed biotype. And here the three lines represent the three different provinces. And in Alberta, currently, we're sitting at about 59% of fields that are sampled show up with a herbicide-resistant weed biotype. And when this is combined with some mapping of the weed populations that are sampled, and then also a grower management questionnaire, we can get a lot of value from this information. So the questionnaire asks questions about whether the growers expect that they have herbicide resistance, what are some of the management practices that they use on their farm, and also ask questions about the perceived cost of herbicide-resistant weed biotypes as well. And this information can be used or aggregated to determine essentially a cost of herbicide resistance for whichever region we're interested in. So in this case, just a few stats. So almost 24 million acres of the prairies are infested with herbicide-resistant weeds. And this costs prairie growers about $528 million annually, which is a large sum of money. And these metrics are actually based on farmer-reported costs of resistance. So with that, we'll bring up our first poll question. So this presentation is focused on mainly on herbicide resistance testing, which we'll get to. And just in advance of that, we're wanting to know if you're a farmer or an agronomist, have you used a herbicide resistance testing service in the past?
Not sure if you can see it there, Charles, but the poll's running. Once it's done, I'll pop it up there.
Yep, I can see it. So in the meantime, while we're waiting for the answers on that, we'll move on to the status of resistance in wild oat. So to start off with group 1 resistance in wild oat, so group 1s are the ACCase inhibitors, otherwise known as the in-crop graminicides. So they're herbicides used to manage grassy weeds in grass crops, predominantly your small grain cereals. So when we're looking at group 1 resistance, this is one of the main types of resistance in wild oat. We can see that the number of fields where wild oat is sampled, or the percentage of fields where wild oat is sampled, are showing up with greater incidence of herbicide resistance over time. Currently sitting at, in Alberta, 58% of the fields where wild oat is sampled show up with a herbicide-resistant weed biotype. And you can see how quickly that's increased since the early 2000s. Looking at a map of Alberta here, shown as the white dots, these are the resistant biotypes. And you can see the group 1 resistance is fairly widely disseminated across the province. And this will be a common theme for group 2 resistance as well. So moving on to group 2 resistance now, the story is a little bit different, where you see group 2 herbicides are the ALS inhibitors, but they can also be used to manage grassy weeds like wild oat in grassy crops, but also some broadleaf crops as well. And you can see here that between the first round of prairie herbicide-resistant weed surveys and the second round, there was a very small increase in group 2 resistance in a couple provinces. But really that increase wasn't experienced until this third round of surveys that took place between 2014 and 2017. And the reason why we have this sort of delay in group 2 resistance is because essentially in response to group 1 resistance in wild oat, many farmers shifted over to managing those wild oat populations with a different herbicide mode of action, in this case being group 2 herbicides. And that has increased the selection pressure for group 2 resistance on the prairies. So we're seeing now a sharper increase in the incidence of group 2 resistance in wild oat. In Alberta, currently sitting at about 40% of fields where wild oat is sampled. So here we have the poll. So about 47% answered that yes, they do, or they have used a herbicide resistance testing service in the past. And that's actually quite encouraging. So I'm glad to see that, because these can be valuable tools for growers, as we'll get into in future slides. So moving on to multiple resistance in wild oat, here focusing on group 1 and 2 resistance in the same population. You can see, again, looking at the map, this type of resistance is fairly widely disseminated across the agricultural region in Alberta, maybe a little bit less up in the Peace River region compared to the rest. But when you look at the entire province, you can see this follows closely with group 2 resistance. And again, the reason being because most growers shifted over to using these group 2s in response to the group 1 resistance that the populations already had, right? So essentially they're just stacking or selecting for another type of resistance on top of these group 1 resistant biotypes. And in Alberta, we're currently sitting at almost 30% of the fields where wild oat is sampled shows up with group 1 and 2 resistance in their wild oats. So this is just looking at the same information from the 2014 to 2017 survey expanded over the Prairie provinces. And you can see, so here on this map, the group 1 resistant populations are shown in red, the group 2 resistant populations in blue, and both multiple resistance to 1 and 2 are shown in green. So this just shows that these types of resistance are very widely disseminated across the prairies. And often we see a greater frequency of resistance to either group 1 herbicides alone or the group 1 and 2 herbicides together. And again, that's because of greater use of group 2 herbicides in response to already selected for group 1 resistance. So if that wasn't enough, in wild oat on the prairies, we do also have lipid inhibitor resistance or group 8 resistance. So these are this would be a soil-applied herbicide, the active ingredient known as trilate, and the trade names would be Avidex and one of the active ingredients in Fortress. And so the most recent data that we have for the prairies was from the survey that took place between 2007 and 2009, and you can see here Alberta was in the lead for the Prairie provinces as far as 15% of the fields that were sampled showed up with trilate resistance in wild oat. So we don't have a more recent statistic to show you on this, but this is going to be one of our priorities moving forward, is trying to quantify how this has potentially changed over the last decade or so. So of course, this is resistance in wild oat is a significant issue, and these next slides will explain why. So these, what I've done here is use the Blue Book, or the Guide to Crop Protection for Alberta, and pulled out the herbicides that are labeled for control or suppression of wild oat in wheat, barley, canola, pea, and lentil. So some of the main crops that we grow here on the prairies. So these are the herbicide options, and if you have group 1 resistance in wild oat, and here we're assuming group blanket resistance to all of the active ingredients within group 1, then you're losing the efficacy of some of these herbicides, as you can see here. So anything that's red with a line through it is basically a loss of efficacy. Something that is red without a line through it is a loss of efficacy of at least one mode of action that has activity on wild oat. So here, looking at group 1 resistance, Then if we look at multiple resistance, so adding group 2 resistance into that, you can see that the options, especially in the small grain cereals, are getting more and more limited. So it's at this point where we're dealing with multiple resistance, or group 1 and 2 resistance in wild oat, where we have very few post-emergence options for management of wild oat throughout these crops. And in fact, as we'll get into in a second, the only post-emergence options for management of wild oat show up in the canola phase of a crop rotation. So adding in group 8 resistance on top of that, you can see even more limitation for the herbicides that can be used. And again, so all of these herbicides are pre-emergence herbicides, as you can see here with the pre after each of the herbicides, except for Liberty and glyphosate. So these would be the use of these herbicides in either Liberty Link or Roundup Ready crop or Roundup Ready canola. So this shows how important it is to maintain canola in a crop rotation to help with managing herbicide-resistant wild oat. The other important thing is that all of the remaining pre-emergence herbicides, as you can see by the superscript S here, are labeled for suppression only. So it means that essentially we have pre-emergence herbicide options, but they're labeled only for suppression, and we don't have post-emergence herbicide options in this case. So this gets me into a little bit of discussion about different types or different mechanisms of resistance. So here we're looking at some broad generalizations, and this this figure was taken from actually the Bayer website, and because it briefly explains a few different types of resistance. So mainly resistance mechanisms can be broken up into 2 groups. So we have target site resistance versus non-target site resistance, and of which metabolic resistance is one form of non-target site resistance. So if we're focusing first on target site resistance, so essentially a herbicide is taken up by a plant, and that active ingredient would bind to an enzyme target site, and that binding would essentially put in place the activity of the herbicide in helping to control the weed. But when you have target site resistance, it's often as a result of a simple mutation, genetic mutation, which alters the target enzyme site, making the herbicide less able to bind to that target site, and therefore having less activity. Looking at metabolic resistance, though, and other forms of non-target site resistance, so these types of resistance are not due with an alteration in the enzyme target site, but rather various mechanisms reducing the amount of the herbicide active ingredient reaching the target site in the plant. In the case of metabolic resistance, it's a selection for plants that have a higher metabolic rate, and therefore these plants are actually breaking down the herbicide active ingredients before the active ingredient can reach the enzyme target site. So we're seeing a less efficacy of the herbicides in that case. So again, there can be some broad generalizations among these different types of resistance. So again, focusing on target site resistance first. So it's usually a simple mutation to the enzyme target site, and this confers often a higher level of resistance initially, but this mutation is naturally present. So these are naturally occurring mutations in a very low proportion of individuals within a population. And it is only with repeated use of that herbicide mode of action over time that you're selecting for a greater number of those resistant individuals within the population. And also, so because of the target site resistance is related to the specific enzyme target site, there's a lower potential for cross resistance to multiple modes of action. And it is in this case that herbicide rotation or herbicide mixing could help mitigate or manage this type of resistance. When we compare that to something like metabolism-based resistance, this is generally a slower selection for resistance, or a slower selection for individuals that have a higher rate of metabolism, or they can metabolize that herbicide more. Often it's due to either intentional or unintentional use of lower rates of the herbicide, so essentially killing off plants that have the lower rate of metabolism, but keeping plants that have a higher rate of metabolism. And this is something that builds over time. So the issue with metabolism-based resistance is that it's not necessarily related to the target site, which means that it can have a higher potential to develop cross-resistance to other herbicide modes of action. And in some cases, you can actually select for a metabolism-based resistance, but with say one herbicide mode of action, but this can confer resistance to another herbicide mode of action, or even a herbicide mode of action that has not been developed or released yet. So this is why metabolism-based resistance and other types of non-target site resistance are a large concern in the weed science community. And when we're talking about the resistance being less related to the herbicide mode of action, obviously herbicide rotation or mixing may be less effective at mitigating this type of resistance. So this is where non-chemical weed management really comes into play. So the reason why I was going through these different types of resistance is because wild oat actually can have both target site and metabolic resistance. So this can obviously create issues, especially when it comes to genetic testing for herbicide resistance, but also the wide diversity in types of resistance that we see across the Canadian prairies. So here we're looking at 20 different populations here on the y-axis here. And you can see across the top we have various herbicides. So these are all herbicides within the group 1 mode of action or ACCase inhibitors, and broken up into 2 chemical families within that mode of action. So these are the aryl oxyphenoxypropionates, otherwise known as the FOPs, and here these are cyclohexane diones, otherwise known as the DIMs. So we're comparing FOPs here and DIMs here. And what I wanted to show with this, so here we're looking at the percentage of individuals in the population considered resistant to this herbicide active ingredient. So a darker red color indicates a higher level of resistance in the population. And obviously, if there's no red, that means that it's susceptible. So these are samples that were collected from the Canadian prairies, and you can see that even within the group 1 herbicide mode of action, we do see variable cross-resistance to these active ingredients. So if you have group 1 resistance, you don't necessarily have group 1 resistance to all of the available active ingredients for wild oat management. As you can see here, by a combination, here we're showing resistance to the FOPs, but not the DIMs in this case, right? So this means that growers still might have options or chemical options for management of some of their resistance problems when it comes to wild oat. The other thing to point out here, looking at clethodim, don't misinterpret this. So we do have clethodim resistance on the prairies as well. Resistance to clethodim in wild oat generally shows up in a lower number of the populations, and clethodim would be the active ingredient in herbicides like Select or Centurion. So this would be the group 1 herbicide included with Liberty, say in Liberty Link canola. So now looking at the same thing, but with group 2 mode of action this time. And you can see generally when we see resistance to group 2 in wild oat, we often see more of a broad cross resistance to most of the active ingredients within that mode of action. And again, so these variable cross resistance patterns are due likely to variable mechanisms of resistance, whether it be target site resistance, non-target site resistance, or a combination of the two. So moving on to kochia now. So the story for kochia in Western Canada, first of all, group 2 resistance was found in the late 80s, and over the course of 2 decades, group 2 resistance spread to the point where we now consider all kochia populations in Western Canada resistant to group 2s or ALS inhibitors. Then in 2011, following the 2007 discovery in the United States, in 2011 we found glyphosate resistance in kochia, first found in Warner County here, just in southern Alberta. And the subsequent survey in 2012 identified that 5% of the populations at the time were considered glyphosate resistant. Then you fast forward 5 years later, and in 2017, the incidence of glyphosate resistance increased from 5% to now 50% of populations in 2017, shown here by the red and green dots. And in addition to glyphosate resistance, the researchers also found dicamba resistance, which is another mode of action with synthetic auxins. Here shown in either blue or green. And the green here shows multiple resistance to group 2, 4, and 9. So ALS inhibitors, dicamba, and glyphosate. So the next survey of Alberta is planned for 2021. And it will be interesting to see how the landscape as far as resistance in kochia has changed in Alberta over this time frame. Just based on my observations, I'm guessing that we'll see a greater incidence of glyphosate resistance and auxinic resistance in Alberta. So some further research here with the 2017 kochia samples. So one of the questions that many farmers and agronomists had was based on dicamba, the newly found dicamba resistance in kochia in the prairies, and whether resistance to dicamba meant that these populations were resistant to other synthetic auxins as well. So synthetic auxins are generally used in small grain cereals, and they usually have high efficacy for management of kochia that is susceptible, but unfortunately that's not the case for these resistant biotypes. So another mode of action, another active ingredient that we use quite commonly on the prairies for kochia management is fluroxypyr. So we wanted to quantify whether there was overlap in the dicamba and fluroxypyr resistant biotypes. So here you can see that there was some overlap, and about 4% of the populations had resistance to both dicamba and fluroxypyr, but the majority of the auxin resistant populations were resistant to either one or the other. So this can be, it's sort of good and bad news. We'll start with the bad news, is that synthetic auxin resistance is actually present in a greater percentage of populations than we had initially thought. So about 28% of the populations in Alberta. However, if you have dicamba resistance, it may not necessarily mean that you have fluroxypyr resistance and vice versa. So we found dicamba resistance in about 18 or 19% of the populations, and then fluroxypyr resistance in about 14% of the populations, or 13%, but there really was only overlap in 4%. So in the future, one of the big risks when it comes to kochia, at least from my perspective, is PPO inhibitor resistance. So this is something that hasn't been found yet anywhere. But in response to the rapid increase in glyphosate resistance, we're now seeing farmers shifting over to adding another mode of action pre-emergence. In most cases for kochia management, this being the PPO inhibitors or the group 14 herbicides. So that is just increasing selection pressure for that type of resistance in kochia populations. So moving forward, this is something that will need to be monitored. So digging a little bit deeper into the 2017 Alberta kochia survey. So here in this map, we're looking specifically at glyphosate resistance, and here we're looking specifically at dicamba resistance. And we're breaking out the populations into what we're considering susceptible, low resistance, moderate resistance, and high resistance. And so low versus moderate versus high, this is the percentage of individuals considered resistant within those populations. Just for your reference, low being between 1 and 20% of the individuals in the population considered resistant, compared to moderate, which would be 21 to 60, and then high resistance being 61 to 100. So this is important, especially when you look at the map and you see the number of populations that have a lower level resistance, so shown by this light red color here. Because generally in fields, we see farmers or agronomists actually knowing that they have resistance visually, that level would be somewhere between 20 and 30%. So many of these light red populations, at least at the time, were probably going unnoticed by farmers and agronomists, but the unfortunate fact is that there is resistance there, and it's likely increasing with repetitive use of that mode of action. You can see a same thing with dicamba resistance, where we have a lot of light green populations here, mixed in with a few darker green populations here and elsewhere. But the dicamba resistance, at least that showed up in this survey, was more isolated to the southern part of Alberta. So once you get up past Calgary, all of these samples actually showed up resistant or susceptible to dicamba. Now looking at fluroxypyr resistance over here, you can see sort of a similar story. So lots of lower level resistance. There is maybe a greater frequency of either moderate or high level resistance in fluroxypyr. But again, a similar story to dicamba. However, some of the fluroxypyr resistant populations were showing up up past Calgary. So this brings me into the third part of the presentation. So we'll start off with poll number 2, Jeremy. So this poll is asking about the adoption of herbicide resistance. So which of the following would most lead to a greater adoption of herbicide resistance testing by either farmers or agronomists? And we'll continue on while you're answering. So around this time of year, I often get calls or emails from farmers or agronomists that have fields that look like this, and they're wondering what should they be doing when it comes to herbicide resistance testing. And truly, I believe that there's not enough information out there on the potential options for herbicide resistance testing. And obviously this is a very important tool for farmers to utilize. So here you can see wild oats throughout a small grain cereal field. And the question is, what's the best way to sample? Where should I send these samples? And how can I get them tested for resistance? So that's what we're going to talk about moving forward. So first of all, this information is coming from the recently formed Resistant Wild Oat Action Committee. However, the general sampling guidelines apply to a whole range of weed species. So the recommendations are quite similar among weed species. The thing that does differ is sometimes in the timing of sampling. So when we're talking about species like wild oat, they're mature often before harvest. So right now, before harvest is the best time to go in and sample weeds like wild oat for resistance testing. Comparing that to some later maturing weeds like either kochia or Russian thistle. For Russian thistle and kochia, we usually sample after harvest. So these would be done in post-harvest surveys. And we usually would sample sometime in October. So in general, when we're talking about resistance testing, one of the main things is that most resistance testing currently is actually done on the seed from the weed plant, right? So essentially the seeds are collected, they're grown out in the greenhouse and treated with various herbicides to see whether they're resistant or not. So in this case, we're looking for clean and mature seeds. So mature seeds having a greater germination percentage, it increases the validity of the resistance testing. In addition, we're looking for about 2,000 seeds per sample that you would like tested, or per subgroup within a herbicide mode of action. And in wild oat, that would equate to about 1 to 2 liters of seed from an individual field that could be tested in the greenhouse or in a growth room. And so essentially collecting the seed, making sure to dry down the seed. So we're looking for dry seed because obviously seed can be quite susceptible to mold, especially in the shipping process. So essentially collecting the seed, drying it down, packaging it up, and filling out the form, and then sending it along with the seed sample. So for wild oat, an easy trick, I don't have a photo here, but is just to use something like an insect sweep net. So actually sweeping the heads of the wild oat plant, essentially you'll dislodge any mature seed, and that seed will have greater viability when we're doing our testing. So that method actually does work out quite well. So this is an interesting result from the poll. So it appears that the opinion is that we need everything but a lower cost of sample submission. which is quite interesting. And I would have to agree. I mean, that question may have been, it might have been a little targeted, because I think that we do need more information for sure, but also there's great utility to the development of rapid genetic testing as well.
Charles, I have someone who's raised their hand, Blair Goldade, looking to ask a question. Do you mind if I?
Yeah, go ahead.
He may have taken it down now. Okay, never mind. He changed his mind. I'll have to bug him about it later. Let you keep going at it.
All right. If he still has a question, just feel free to type it in the chat or put up your hand again. Okay, so moving on to things that we shouldn't do when we're sampling for resistance testing. So it's always nice to have clean seed that's free of diseased seeds or immature seeds like green seeds that won't have the same viability. In addition, any fields that are treated with a pre-harvest herbicide, so pre-harvest herbicides can impact seed viability, especially when we're talking about herbicides like glyphosate. So it's best to have seed that hasn't been treated with a pre-harvest herbicide. Then when we're talking about packaging here, it's best to use some type of a paper bag to make sure that those seeds can still breathe. But obviously the most important thing is that the seeds are dry at the time of shipping. And then completing the full request form and submitting it to one of the various labs. So when we're talking about where to submit these samples, so it's not an exhaustive list of resistance testing options across the prairies. These are some of the main ones that I am aware of. And again, this is another infographic that was developed by the Resistant Wild Oat Action Committee. So when we're talking about various labs, first of all, on the top here, we have the Crop Protection Lab with the Saskatchewan Ministry of Agriculture out of Regina. And then we have ACCase out of Minto, Manitoba. So these labs, they offer sort of the standard for resistance testing, which again is on the viable seed from weeds. Growing these weeds out and treating them under controlled environment with various herbicides and looking at how the phenotype responds. So these labs offer various types of resistance testing for various weed species, and also within herbicide modes of action as well, selecting for different chemical classes or different chemical families. So you can see here group 1 resistant wild oat can select for resistance to the FOPs, the DIMs, or the DENs. I'm just looking at the chat there. So so another resistance testing lab here is the Pest Surveillance Initiative out of Winnipeg, Manitoba. So currently their testing is actually a genetic testing. So it's a tissue testing for glyphosate resistance, a group 9 resistance in kochia. So when we're talking about genetic testing, again, this is tissue, so it's not on seeds. And the idea is that you can test green tissue during the growing season and get a rapid answer on whether you have resistance in that same growing season. So this type of testing can have a lot of value for farmers, especially when it comes to determining alternative management approaches in that same season. But there are some costs because to develop a genetic test, you need to understand the herbicide mechanism or the resistance mechanism within that, or resistance mechanism within the sort of unique herbicide-resistant weed biotype. Another research lab is a Prairie Resistant Research Lab, and so this is actually my lab based at Agriculture and Agri-Food Canada in Lethbridge, Alberta. And the type of testing that we offer is a little bit different. So we do these widespread surveys across the prairies, but in addition to that, we also offer free testing that is confidential for novel herbicide-resistant weed biotypes. And what we mean by novel herbicide resistance are types of resistance that are suspected on the prairies, but not quantified yet, or they're types of resistance that we do not know to occur currently within the province. So if a farmer or an agronomist suspects that they might have resistance that hasn't been documented previously, they can contact me at my email here, and we can move forward from there. But we can sample the field and do some free testing to diagnose whether it's resistant or not. And the types of testing generally vary when you're talking about novel resistance versus something that is fairly commonplace, like group 1 and 2 resistance in wild oat. So as I mentioned, one of the common methods for quantifying resistance is growing the plants out, treating them with a herbicide under a controlled environment. Here we have our controlled environment track sprayer. And here's an example of some of our kochia survey work. So in this case, each tray is a population, and in each well within the tray is a different individual plant. The idea is that we're testing multiple individuals within each population for resistance. In this case, it was resistance to glyphosate. So again, when we're talking about diagnosing novel resistance or things that are not as well characterized, here I have an example of some of the work that we were doing on fluroxypyr resistance in kochia. So you can, one of the types of experiments that you can do are called a dose response experiment. So here each line is a different population, and we're looking at known susceptible populations versus a known resistant population versus our populations in question here. And here we're pulling out the higher type of resistance or the populations that have a higher level of resistance, just for a visual. And you can see that we're looking at the response to various rates of the herbicide for each of these populations and comparing among them. And you can see with resistance in fluroxypyr, at least in these populations we were testing, you're seeing a shift over to requiring a much higher rate of the herbicide to achieve the same level of control. And when we're talking about field rates, we're talking about somewhere between about 80 and 140. So it would be somewhere in this range. It would be what farmers are applying in the field. And here you can see one of a susceptible population compared to a resistant population and how the response varies, especially for fluroxypyr resistance in kochia. So for novel resistance again, so I'm focusing on this because this is something that our lab offers. So if you contact me at my email, I can send you out this sample submission form. And essentially we'll offer free testing for these novel resistant weed biotypes. This year, we're still considering auxin resistance in kochia a novel type of resistance because it's something that we're still characterizing, and also the other diagnostic labs don't necessarily have a standard test for that type of resistance at this time, so we're still developing that. Other things that we're interested in are PPO inhibitor resistance in kochia or glyphosate resistance in any other weeds other than kochia, and various other biotypes. So to determine whether a biotype has suspected novel resistance, you can go to websites like weedscience.org to see what types of resistance we have on the prairies. You can also look in your blue book or your crop protection guide, and near the start of the book, there's a list of all of the herbicide-resistant weed biotypes that are present within each province. So you can consult that list as well. So moving on to poll number 4, and we're very near the end of the presentation here. So would you use a free confidential resistance testing service if you had a biotype that you suspected had a novel type of resistance? So while you're answering that, we'll address that at the end. And in conclusion, so we have about 26 unique herbicide-resistant weed biotypes on the prairie or in Alberta, and the incidence of resistance is increasing as we've documented here. So that's actually that's very good to hear that there's no no's. So I'm really happy to see that. So everyone that answered, at least the 7 people that answered yes, that's great. So again, herbicide-resistant weed biotypes are increasing, and pre or post-harvest scouting is very important for collecting samples that can be submitted for herbicide resistance testing. And again, most of the weeds are collected pre-harvest, but there are some weeds like kochia and Russian thistle that we recommend collecting later on, sometime in October. And finally, resistance testing can be an essential component of an integrated weed management program because it can identify potential herbicide tools that still remain effective on some of your resistant weed biotypes. So with that said, I'd like to thank everyone for listening. I'd also like to thank the various funders of our resistance work, as you can see here, and our co-investigators, as well as technical staff. And I'd also like to specifically thank the 5 students that were working on developing our prairie maps for herbicide resistance this summer. So thank you very much, and we can take any questions.
We do have one question so far in the chat. If you want to take a peek at that, Charles. The question is from Krishanthi, who I believe is up in the Fort Vermilion area. What are the best commercially available herbicides for wild oats and kochia currently, both pre-emergence and post-emergence? Thanks for the interesting presentation.
Great. So that's an excellent question, and it's unfortunately not one that I can answer. So as a public researcher, we actually do not compare the efficacy of herbicides necessarily. So it's we're supposed to avoid identifying certain trade names that could be associated with specific chemical companies, right? So it's something that's difficult to answer. But when we're talking about active ingredients, right? So talking about wild oat, there's a wide range of active ingredients, and as we've shown here, it really depends on specific fields. So wild oats, they're primarily a selfing species, which means that the resistance that you're seeing in a field was either selected for in that field, or it's due to potential seed contamination with equipment or something like that, right? So it's often unique to individual fields. So in general, like in the group 1s, you have FOPs, DIMs, and DENs, right? So one of my recommendations would be, if you think you have resistance to a herbicide that falls into, say, the FOPs, for example, it could be a good strategy to either try a group 2 or try a different chemical family within the group 1s, like either the DINs or the DENs. Usually with wild oats on the prairies, we see a greater frequency of resistance to the FOPs than the DIMs or the DENs within group 1. So that could be a good strategy. Then okay, there's another question that we'll address after here. Then if we're talking about kochia now, there are various modes of action. The group 14s in general are quite effective for managing kochia pre-emergence. So again, these are things like saflufenicil or Authority, for example, or sulfentrazone, for example. But within the auxins, generally the best thing that we had to manage glyphosate-resistant kochia were the synthetic auxins. So the idea was dicamba and feroxypyr were 2 very good herbicide active ingredients that worked well on kochia if you don't have that resistance. So the answer is a little bit more complicated than just saying this is the herbicide that you should use, but really the approach is that you need to include a variability of herbicides within your management program, right? And not, if you see good activity with one herbicide, don't just stick to that herbicide. You still need to be rotating among them. Okay.
If I'm not sure everyone can see the Q&A question, so I'd say, Charles, before you answer it, just repeat it and then go for it.
Okay. So the question is, how do you manage resistance with the many flushes of kochia in a season? So that's an excellent question. So one of the issues with kochia, so herbicide resistance is part of the issue, but it's not the entire issue with kochia, right? So the the species has several unique biological characteristics that allow it to be a very problematic weed, whether it has resistance or not. So one of those being what we call prolonged emergence periodicity, which means that essentially you don't just have one emergence of kochia and then it's done for the year. Often you'll have a lot of the population emerge very early in the spring, and that can easily be controlled with a pre-emergence herbicide at the moment. But then after that, you'll have a lower number of individuals that emerge throughout the growing season, and it can be essentially throughout the growing season. So some preliminary work has shown that kochia can emerge up to mid-August and still produce viable seed before the end of the year. So that's a large issue with managing kochia, especially when we're talking about these biotypes that now have resistance and how we manage those. And I think the answer is it doesn't necessarily lie with herbicides, right? So I think it is relying on some of those non-chemical tools. One that's showing very promising in our work is trying to promote a crop that can be as competitive as possible. One of the big things with kochia is that it produces a large number of seeds, but if you have a competitive crop, it will respond to that and seed production will drastically decline. So the idea is to integrate non-chemical tools to help manage those later emerging biotypes.
So we have a second question in the Q&A there. Charles, if you want to tackle that one as well.
Okay, so does spraying glyphosate in the fall on actively growing kochia have any effect on seed germination in the spring? Does it negatively affect the germ even if the plant is resistant? So this is something that we're actually currently working on trying to quantify. So we've had field experiments that started in 2018 and are ongoing to look at either pre or post-harvest herbicide applications and what they do to viable seed on kochia plants. So some of our preliminary results, again, these are preliminary, they're showing that both a pre-harvest and a post-harvest herbicide can be effective. You don't necessarily need to have both of them, but one or the other. If you apply your pre-harvest herbicide, in our research, we were looking at glyphosate and saflufenicil pre-harvest, and that can decrease the viable seed on the kochia plants when it comes to harvest. It doesn't completely eliminate viability, but it does decrease it by a certain proportion, probably about a third to a half of the viable seed. So that can be an effective tool to help decrease some of the seed. And again, one of the issues with kochia is that after earlier harvest dates, it can actually regrow and produce more seed after harvest. So that's where the post-harvest herbicide comes into effect, right? So if you have an earlier harvest date, our research is showing if your harvest date is sort of early September or before, you'll see regrowth in those kochia populations quite likely. So using a post-harvest herbicide can actually mitigate that regrowth and almost eliminate any seed production on the regrowth.
Wonderful. We are coming to the end. I'm going to have one last question for you, Charles, and maybe it's a little bit of a heavier one and maybe we won't have a solid answer for it, but Hugh Becky recently put out a paper talking about, what's the potential options if we do lose glyphosate in different manners, and looking at some of the information in terms of options when we look at group 1 and 2 resistant wild oats. We're kind of left with in-crop herbicide-resistant crops as an option to control that. But if we, potentially lose glyphosate as a pre and post emergence, and then there's increasing glyphosate resistance in kochia, it kind of leads us to a pinching point where we're limited on options for wild oats. And those options then increase our chance of creating glyphosate resistant kochia. What kind of direction do we need to be heading in? Do we need to be thinking about other things to kind of steer us away from this pinching point, or is it maybe a non-issue? Just curious of your thoughts on that, Charles.
Yeah. So you're right in that's a heavy question. It's difficult to answer, but I think in general, obviously there has been some public scrutiny of glyphosate in the press, right? And obviously we have other issues with glyphosate, such as increasing incidence of glyphosate-resistant kochia, right? And it's no secret that contemporary crop production in Western Canada essentially relies on glyphosate, mainly applied pre-emergence, right? So I think the answer to that question is going to be quite complex, right? I think that there may be some other options when we're talking about pre-harvest herbicides and trying to mitigate any potential residues in seed shipments, right? I think there might be some other alternatives there. But when we come to pre-emergence herbicides, glyphosate is heavily relied on in the prairies. So it's not, I don't think it's something that it will be able to shift away from overnight, or necessarily that we even should shift away from at this point. But there needs to be more research into what other options are out there, right? From both a chemical and a non-chemical standpoint. And I think really any potential solutions in the future will be a combination of those, right? We're quickly losing our chemical options, and currently the only way that we have to preserve them is including non-chemical weed control in those weed management programs. So I didn't answer your question directly there, but it's because I don't have an answer for you.
Kind of a loaded question, Charles, for sure.
Yeah, and I see that we have another question here in the Q&A. So the question is, does winter wheat or fall rye compete well with wild oats? And I think that the answer, especially for Western Canada, is that it is that winter cereals can be better than spring cereals. Obviously, many of the herbicide options remain the same, but the big thing is the timing or the phenology of those crops, right? So when we're talking about including a winter annual in a crop rotation, it can always be beneficial for managing a summer annual weed. And in Western Canada, compared with other parts of the world, wild oats are a summer annual weed. So the earlier harvest timing that we achieve with winter cereals can help, because we could, especially if we're thinking about catching all of the wild oat seed with something like harvest weed seed control, right? So an earlier harvest timing means that wild oat has not shed as much seed into the soil seed bank. So I think that those two can be quite effective. The other question is when it comes to cover cropping, and I don't think that so thinking about cover cropping with something like fall rye, for example, and I don't think that there's enough information out there currently to come up with a solid answer for that. I do know that some of our preliminary work with fall rye cover cropping is showing that fall rye can be quite effective, I think, at managing kochia. So that is I guess, a good tool that farmers could probably use in their crop rotation. But again, we need to characterize it more further, or further, I guess.
Yeah, it's interesting, asking the question about what other options when we're heading towards this pinching point of losing chemicals and increasing resistant weeds. And I think some of these other cropping options that don't align with our kind of more prevalent crop systems, so something like a fall seeded crop, can definitely be one of those tools to help mitigate resistance. So I think it's interesting that question kind of comes after. But we are a little bit over time, so I'll just say definitely if you're looking for more information, go check out Charles's past webinar. There is some discussion on looking at different patterns in weeds in the fields to identify them as a potential risk for resistance, and you can carry that into harvest timing. And then it's great to align this with options of where to send it into for resistance testing. So it all works very well together. So I'd highly encourage go and checking that out. So thank you, Charles, for a great presentation. I hope everyone found value from this. And everyone keep in mind, this can be found, we're recording this, so you'll be able to find it on our website or on our YouTube channel at a later date. And again, this is our last webinar, our planned webinar for the season. So unless something comes up, I want to thank everyone who attended any of our webinars for joining, and all of our presenters. It's been a great series, and there's a lot of information. So thank you to everyone, and enjoy the rest of your day.
Great. Thanks everyone for listening, and also thanks to Alberta Wheat and Alberta Barley for putting on these webinars.